they have these cosmic filaments, okay? You've seen them before probably, and they say, oh, look, that's plasma or gases that are carrying electricity from one galaxy to another, one star to another. And the first problem that you need to be aware of in this scenario is this, and that is that, you know, between two galaxies, you cannot have electricity flowing like they say, because there's no matter between them. And this is where we run into trouble with the electric universe. You know, you can't say that that these filaments exist, because you would need matter and to carry the electricity or to conduct the electricity. And there is no matter out there in space. So this is where the theory falls apart. You cannot have electricity just flowing through empty space without any atoms. You need atoms to do physics to begin with, but electricity specifically. Okay, so this is the universe, okay, more or less a bunch of stars, okay, and you can see there's a lot of black stuff in there. So the universe is filled primarily with nothing. It's not filled at all. And so what these people are suggesting essentially is this, that they're going to fill with matter the entire universe. And you say, but this is irrational. There is no matter out there. Here you have another version of that. Okay, you have the universe as we more or less see it at night. And they say, well, look at all that stuff. And there is not so. Most of it is black. And what they do, they fill it with, you know, again, a bunch of particles, because whether they do it deliberate, specifically or inadvertently, is not the issue. The issue is that there is no matter out there. Okay, and so you cannot have this scenario where you have all these particles, the ether, as it used to be called, and that fills in the blanks so that they can conduct electricity. So that's where, again, the electric universe fails. Okay? I talked about the other day about the vacuum levels, and these are numbers that more or less, you know, they have out there, but you'll find all kinds of numbers really. The important thing is the level, the notion of vacuum or pressure, if you want to look at it as pressure, out there. On the moon, it's in the range of 10 to the minus 8 to 10 to the minus 12 torr. You see there like maybe anywhere from 200,000 to 1 million particles per centimeter cube. That's what they claim is out there. NASA claims that they measured it in Apollo 14 and 15 in the minus 12 range, which again is like 200,000 particles per centimeter cube according to them, or according to the calculations, right? When you go to interplanetary pressure, right, you get a wide range, all the way up to negative 17, typically in the negative 12 torr range. Interstellar pressure, calculated because we don't know, but maybe anywhere from minus 16 to minus 19 torr level. And when you get to intergalactic, between galaxies, right, maybe you're in the negative 25 range. And again, these are not solid numbers, but you can get an idea that the farther out you go, if you traveled from one galaxy to another, there's nothing there in space. That means that space is something different than the stuff that you could say fills it, right? And we'll get to that in a second, talk a little more about that. But the point here is that, there's not enough matter out there. Now, I worked in the semiconductor industry for many years, and we worked in the minus 7 range, minus 7 torr range, and you cannot conduct electricity in the minus 7 range, period. You can't. Maybe an arcing every now and then, a zap, you get that we had, but you don't get constant electricity. You cannot conduct electricity at minus 7. In order to conduct electricity, we had to fill the vacuum chamber with argon and inert gas and take it back to the minus 3 level, minus 3 torr. Then you can conduct electricity, because now you have some matter in there that you can ionize, and now you can conduct electricity. You cannot ionize, you can probably ionize, but you cannot conduct electricity in the minus 7 range, let alone what these people are suggesting in the minus 12 and lower range of vacuum. So again, the electric universe does not understand, these people don't understand that there's no matter out there, and what little matter there is not sufficient to conduct constant electricity. So you have people like Walt Thornhill saying that all the stars are like connected by, like on a Christmas tree. Totally irrational. You cannot have electricity between the light bulbs, the suns, the stars, right? Because there's no electricity flowing from star to star. Aside from the fact that you would have to tell me why one star is positive and the other one is negative. Why does the electricity go to the positive star, right? And which ones are positive, which ones are negative, Okay, now this version of the electric universe, where space is filled with stuff, is also the one that we have from the established, from quantum mechanics. Here's, in fact, an article I pulled up a couple days ago, and they say exactly what these people believe in. And it says, new study suggests light can form without any matter at all. But it says, in quantum field theory, a vacuum is never completely empty. Electromagnetic particles like electrons and positrons are always passing through in particle or wave form. Empty spaces in the dark only appear to be complete voids. Even intergalactic space has a few hydrogen atoms per cubic meter. But if that's the case, that means that there are empty spaces, or more empty spaces than other regions, right? Because if you go into intergalactic space, now you have fewer atoms. That means most of what you find in that cubic meter is empty space and not atoms. But they don't realize what they're saying. They're saying all space is filled with objects with atoms or some form of wave or electromagnetic radiation or whatever. And so they say they give you the impression that there's no amount of empty space. Every bit of space is covered by something. And quantum field theory suggests that even in regions of space where there's absolutely nothing physical, there are fleeting electromagnetic particles and waves that come and go. In other words, again, they say there's no such thing as empty space. But then the question is, what gives shape to the particles or the electromagnetic waves that come and go? How do you distinguish one wave from another if there's no such thing as empty space? Which serves as a background to all these things. And it says, welcome to the quantum vacuum. Yeah, quantum vacuum is irrational because they never specified what they mean, if there is such a thing as empty space. Simulations have shown that light can be created out of nothing. Oh my God. The quantum vacuum is filled with energy fluctuations, whatever that is. What's an energy fluctuation? They never defined energy. They don't know what energy is. Dick Feynman famously said, we have no idea what energy is. Yeah, exactly. From which virtual electron-positron pairs arise. So they have this so-called energy, which is photons, and from photons and probably antiphotons or dark photons, then you have these virtual electron-positron pairs that pop in from, into existence. So this is just magic. This is Alice in Wonderland nonsense. It's they cannot explain the process. They just say it is so. We measured it. So we don't know what they measured. So all we know is that they're saying is that energy turns into, which is a concept, right? Turns into these two particles, electron-positron pairs, which are not particles either. They're just a bunch of numbers. So we have a bunch of abstractions there, which they talk about, and none of it has anything to do with physics. Says the presence of these virtual particles creates nonlinearities in vacuum that interact with high power laser pulses propagating through. So yeah, the notion that the establishment has, the quantum mechanic people, is that there's no such thing as empty space. Every bit of space is filled with something. And then again, we have a problem because if every bit of space is filled with something, what gives shape to each one of those little thingies that fill space? And to make it work, they invented these virtual particles. The virtual particles are simply magical particles that come in and out of existence, they say, constantly. And so they just say, well, we need it for the math. We have a factor we cannot explain, and we'll call that the virtual particle. So, and when you look at it, the virtual particle is simply something that converts into particles. So they have these particles converting into particles, into particles, into more particles. That's all they have. At no point do you find, absolutely nothing. The famous energy is also particles, mediated by particles. And what is space? Made of particles, or filled with particles. So much so that each particle is next to the other one. Like if they were cubes and there's no space in between, but then you say, well, how can you distinguish one particle from another if there's nothing separating them? And again, they never fix this problem. They never tell you what space is. And and if it's filled with everything, what is the thingy, or whatever you want to call it, what serves as a backdrop to separate one thingy from another thingy, one particle from another particle, one wave from another wave, one energy from another energy, one electromagnetic radiation from another electromagnetic radiation. To say that there's nothing there to separate them, what are you saying? How can you distinguish one entity from another? And for that, you need a backdrop. And they never worry about the backdrop. They skip the backdrop. They never explain that one. Anyways, here we have our ropes. And people say, Bill, if all your ropes crisscross through space and there's no little bit of space that's not covered with ropes, you've got the same problem. And that's not true. Here you see the ropes, okay? And every atom in the universe is connected to all others. And what you're seeing there is that there's some black stuff that serves as backdrop not only to the atoms but also to the ropes. Hopefully every single rope in the universe can be distinguished because there's a backdrop to it. It's not completely filled in such a way that there's no empty space. And here, here's a static version of that. You got to tell me what the black stuff is. So you can't say that the ropes are completely covering every bit of space. That's irrational to say that. Okay? And I'm sure that if we go out between two galaxies, we're going to find fewer ropes, fewer atoms. Therefore, there is more empty space, more black stuff, and less visible or atoms or whatever, less energy. So there's something called space, and we need to identify what that space thingy is. What is that backdrop? What do we call it? How do we define it? We need to figure it out. We need to establish what it is. And this notion that there's no such thing as empty space already came from the Greeks. Here's some of the schools that the Greeks had in the old days, and a couple of those, like you see at the bottom left, the Eleatic school, they believe there's no such thing as empty space, and in fact that there's no such thing as motion. You say, what do you mean there's no such thing as motion? Yeah, they actually believe there's no such thing as motion because the thing would have to move to some place, but there is no such place that the thing can occupy, and essentially the thing would have to disappear, meaning it goes out of existence, and therefore meaning again that space cannot exist because it's not there. It's a kind of roundabout argument. And here you have Parmenides, and he's going to give you the lesson. Okay, he says the following. He says, nature of reality is a single unified being. Being the one, right? God maybe, is everywhere. Yeah, like God, right? Being is unchanging and eternal. Being exists independently of time and space. So being is not space or time. It's a thing that exists, whatever exists means, right? And there is no space that is not filled with being. Motion and change are impossible because what? Would require space to be empty. And hopefully space is empty. Empty space is impossible. Why? Because void is existence of non-being, nothingness. Yeah, that's what void is, nothingness. But they said nothingness cannot exist. Non-being, in other words, it's non-existence. That's what space is. But they don't realize, they're defining properly what space is. They just didn't believe that there's such a thing as non-existence. Okay? And so movement into non-being is a way of disappearing. And since non-being doesn't exist, the object has no place to move into. And what was existence? A unified and changing whole. In other words, that's their notion. That was the notion of the Eleatics of what they thought existence was. So they ended up, with this corollary saying there is no such thing as space. There's no such thing as space, and therefore there is no such thing as motion. But they believed in time, whatever that was, which is a comparison of two motions, right? Okay, and this is Aristotle's version. He said, space and matter are not separate entities. Space is not equal to an infinite void, and space is not equal to empty or nothingness or vacuum. Space is finite. So it's an object, right? Because it's finite. It's spherical, okay? And we have the shape of space now, which is the same as, by the way, of general relativity. And it's a structured entity, okay? Space inseparable from matter. It's the same thing. In other words, position or the location occupied by an object, that is space itself. Okay? That's what it's occupying. So there's no such thing as space outside of matter. Space, fluid continuum filled with interacting physical elements. And he famously said, nature abhors a vacuum. A void cannot possibly exist in the physical world. And again, taking their cues from the Eleatics, more or less there. Geocentric, he believed in the Earth being at the center of the universe. There you see a picture on the right. Okay, that's more or less the notion he had, these different levels where each one of the planets was in, and the Earth was at the center. Okay, the universe was simply a bunch of concentric spheres. So no such thing as space according to the Eleatics and according to Aristotle. Now Democritus, he believed in, or he vouched for, empty space. He said all there is atoms and empty space. Okay, so they believed that atoms move somehow in empty space, and there was such a thing as space, or whatever space was. He never defined it, or at least we don't have a definition that survived to our days. But not all Greeks believed that there was no such thing as empty space, but I think most of them did, or that was the majority opinion. And here you have a fellow a few centuries later. His name is Descartes. René Descartes. No such thing as void or vacuum. He didn't believe in vacuum either. Space is equal to the ether. Okay, ether fills space completely except for tiny separations between vortices. He believed in these vortices, these curlicues. Okay, ether is an ocean, the medium of light. Okay, and the disturbance we call light is pressure in this medium. Vortices in this ether are responsible for the accumulation of the particles that form matter and shape solid objects. So that was Descartes' notion. Okay, he did not believe in empty space either. So a lot of people got rid of empty space. Others tried to define it, like Newton. He said there's an absolute space to which you can gauge your motion. That was changed by a few people after him. One of them was Leibniz, who said space is relative in a sense that objects move with respect to objects and not with respect to empty space. And today we have this relativity version which says that, again, everything is gauged with respect to the speed of light and time. So that's how we ended up today. And here you have some of these crackpots of today. Okay, 19th century primarily. And all these crackpots, they believe that there's something called space-time. Okay, and it's not really space-time. In other words, these are not coordinates or dimensions. What they are is number lines. And what they did, they bent the number lines and they said that's gravity. Bent number lines. Why do they bend? Because something weighs the thing downwards, meaning they use Newtonian gravity to explain gravity. But this is what they believed in, and they still do, that there's this net out there they call space-time. And then, they tell you not to take the analogy so literally, but, what are we staring at? What do we have in front of our eyes? We have a net a fishnet. So I have to take it literally, otherwise the analogy is bunk. What's the point of the analogy if it doesn't represent anything? But this is the notion they have of space. I only have 3 dimensions of space there. We cannot put time because we cannot picture, the 4-dimensional world that these people are proposing. So, today we have this space, which is a net, and objects weigh down this space net. Okay? And then they tell you, forget about that, don't take it literally, we were just kidding. So, we don't have a physical interpretation from the mathematical establishment. Is space made out of particles like this? Is that what it's made out of? Or do particles fill space? Is that what we're talking about? What is the notion that we have of space? Is it filled or is it made of particles? That's one issue. And here you have another version. It's little pieces of something, maybe at a very small level. And the question is, what separates one little object there from another? What separates them? What's that line going between these things? I mean, you can tell it's not continuous. Okay, so they have all these notions of what space is, and the question is, has anyone ever defined what space is? Please tell me what space is. Is it an object? Is it a thing? Is it a concept? If it's a concept, please define it. What's the definition of the word space? Vacuum, void, zip, any of those? Nothingness, nothing, right? So we don't have an idea, and you have to get space really understood for your audience to follow your presentation. If you just say and just wave it through, no, we can't follow your presentation because you're going to need space in every one of your images that you put out there to explain your theory. You got a backdrop. What's that backdrop? Well, we call it space. And what is that space? Well, we don't know. It's a bunch of particles. It's this region filled with particles. Well, whatever it is it a container? I mean, what is space? And they never answer that question. And that's where you have to pinpoint them and, keep them there until they cry, because they can't continue on with their presentation until they tell us what space is or define the word space. Okay, so this is our regular notion that we have of the universe. But let's get rid of all the matter, so we just remain with this, with space. Space is that black stuff. That's all space is. Okay, see how nice and neat it is? It's continuous. It's, you could say, made out of a single piece, right? If it's made out of anything. Okay, and again, is there something in there? And we say, no, there's nothing in there because, again, you have these vacuum levels I talked about a little while ago. And you can see that as you go farther out into space between 2 galaxies, the pressure drops, meaning there's less matter out there. And at some point, I guess there are regions where maybe there is no matter or energy or electromagnetic waves or whatever going through there. Okay? So it's primarily vacuum. That's what space is, and what is vacuum? Nothingness. What is that? How do we define this word? That's what we're going to do today. We're going to try to define this word. And let's see if we can start here. Here you have the vacuum on the moon and the vacuum or the pressure on the moon and the pressure here on Earth. You can see the Earth has a lot more matter around it, and the moon is in the negative 12 range, so it's got a lot less matter around it. Partly because it's a smaller object, celestial object, therefore it doesn't hold as much. It doesn't have as much gravity, so it doesn't hold as much atmosphere. The atmosphere in the on the moon is a lot less than what I'm showing there. The Earth has a lot more matter around it, flying around, in our atmosphere than the moon has around it. At minus 12 range, you don't have any atmosphere essentially. You can't breathe on the moon. Okay, so keep that in mind. Don't go to the moon without a helmet. Okay, so here's if you want to have electricity on the moon, right? You would need to create some kind of environment where you put more matter. Okay, so the one on the left, you would not be able to run an electricity, through that low vacuum. If you want to run electricity somehow, directly, with the atmosphere, you would need to really fill it up with atoms. Okay? So let's see if we can send 2 astronauts to the moon. Okay, here are 2 astronauts to go to the moon. Okay, and they're going to be running some electricity using the atmosphere of the moon. Okay, let's see if we can do that. Okay, let's illustrate that. Here it is. Okay, but can they do that? Can they run it with such little, so little atoms, such little vacuum? Can you run it with minus 12 torr vacuum level? And the answer is no. If you want to run electricity on the moon, you would have to do something like that. You would have to fill the moon with particles all over the place. Otherwise, you can't run electricity with so little vacuum. And that's one of the things that the electric universe doesn't always understand. You need atoms to do electricity. Under the rope model, we could conceivably have these are the remember under the rope model, what you have is merged electron shells, and they're spinning in situ. So you have this serpentine, which is what we call a serpentine, and it's you can see why with this physical object running clockwise from one end, counterclockwise from the other end, you can understand now electricity as a torsion that moves around a wire, for example. Okay, that's what electricity is. Let's take it to the moon, see how we do on the moon. Here we go. So this is what it would look like, more or less, if we could achieve it, right, with enough matter on the moon. But in order to do so, you would have to fill the moon with, again, atoms. You need atoms in order to do electricity on the moon. Okay? Can't do it without atoms. That's the bottom line. Okay, so here we have a space summary, and we're going to define space then. What is something, an object, a thing? That which has shape. That's what it is. And then you see some synonyms, okay? What is nothing, otherwise known as space? That which doesn't have shape. So something and nothing are antonyms. One is the opposite of the other, right? One is that which has shape, the other one is that which doesn't. Now we have definitions that we can sink our teeth into. We have scientific definition. Space is not an ocean. Space is not, it has no shape, no surface, no end, okay, because it's that which doesn't have shape. Very simple. Space is not infinite because it is not a thing. A thing is that which has shape, and space does not have shape, so it's not infinite. You cannot use the word infinite to qualify space. The word infinite is an adjective. You can only use it with objects in physics. Okay? So you can't say infinite space. No, it's irrational to say infinite space. What people mean is that you can travel incessantly and never find an edge. That's different use of words. You need to say that it's traveling is incessant through space, and not that space is infinite. Those are two different notions. You can't fill space because space is not a container, and space can neither push nor pull. It's not an object. Okay? Space cannot be created, was not created. There you see God trying to create space. He's going to spend all day long trying to create space, like they did in relativity, where they created space in the Big Bang, right? And you cannot see or touch space. It's not an object. It's not a thing. Okay? Those are the general notions that you should keep in mind whenever you talk about space. And here's like the icing on the cake. Okay, an object is that which has shape, concept, that which doesn't. Okay, and space is a concept, nothing, void, etc. And you cannot have a star there, or an object cannot morph into a concept and vice versa, right? And there you cannot have the sun turn into nothing, into empty space, or have empty space turn into a star suddenly. like they do again in general relativity, where they cannot explain where the singularity, original singularity of the Big Bang came from. Of course they can, because you cannot explain the process. And yeah, an object cannot lose length, width, and height and suddenly become nothing. So those are the notions we have of space. Space is nothing. What is nothing? That which has no shape. We're done. That's the scientific definition of the word space, of the word nothing, of the word void, of the word vacuum, zip, any one of those, right? And that's the opposite of an object, a thing, and that is, that which has shape.